A great big San Francisco welcome to the Microsoft Professional Developers Conference, co-sponsored by Digital Equipment Corporation. We also want to welcome our guests viewing the PDC from movie theaters around the U.S. and Canada, watching live over CUCME, the M-Bone, and international satellites. To start today's session, let's welcome the Chairman and CEO of Microsoft Corporation, Bill Gates.
Well, good morning. It's super to be here and see the incredible enthusiasm that's built up around the internet and using that together with Windows. Today we have not only the group here in San Francisco, but an even larger group that's watching in theaters, over 50 theaters around the country. And I want to welcome them to the Professional Developers Conference. Now, these conferences have really been major milestones in the history of the software business, going all the way back to the original battle of character mode interface versus graphical interface. We used the Developers Conference to bring people in to the graphical world. And that ended up completely reordering the fortunes of software companies, creating many, many new opportunities. The next big milestone was Windows NT. That's one that this year has been very gratifying for, because the investments that we and you have made over many years are really paying off now with the incredible volume of NT, not only on the desktop, but also on the server as well. The last PDC was Windows 95, and that's been the fastest selling software product of all time, with well over 20 million users now. And the broad acceptance has been pretty amazing. It's hard to buy a new machine now without Windows 95. It's over 90% of all new machines, and our upgrade rates have been more than double any previous product that we've had. But today's topic, I think, is even more exciting than any of those, because today what we're talking about is something that's not just about the software industry. It's about the whole way the world communicates. Communicates for business, communicates for learning, or even communicates to socialize and entertain each other. Well, the internet phenomena is truly incredible. What happens when you get to critical mass and you get the kind of positive feedback that we've seen only a few other times in this business is hard to exaggerate what the impact of that is. With the PC, it was interesting to see that over 50 types of PCs were on sale when the IBM PC came out. And yet, even as that volume grew, the idea of a standard coalesced things around the PC as a seed corn. The IBM PC was in no ways perfect. And in fact, as the volume of the market went up, those imperfections were viewed as opportunities by companies like Compaq and dozens of others. And so people rushed in to improve the product, and the amount of creativity that was brought to bear was enough to create the PC revolution. Well, with the internet, the breadth of players is far broader, and the phenomena is happening even more rapidly. Part of that is that the internet is, in a sense, its own distribution system. News about the internet, new internet software, it's all there in the blink of an eye. And so we now know what the seed corn for electronic publishing and electronic communications is. It's all these wonderful protocols, many of which have been around for over 20 years, are what we're going to use as the foundation for this new world. Now, I've talked about the internet as almost a gold rush. There's really no other way to describe the kind of frenzy that's taking place. That's partly reflected in the rising and falling stock prices. I think internet stocks have greater volatility than any category out there. Fundamentally, when you've got a gold rush atmosphere, people sort of suspend disbelief If somebody says, hey, I can do something on the internet, no matter what it is, people are fairly open-minded. They want to invest, start a new company, do an IPO. And these high levels of investment are very, very positive for getting this business going. In fact, as I've gone around the world over the last month, I've gone to some kind of unusual places. I was in Poland, Argentina, all over, and I wondered when I went to those countries, what the level of interest in this phenomenon would be. Is it just confined to the United States? And it's certainly not. If anything, those countries are, in their governments, are even more anxious about this because they worry about being left behind. And so although for the first 15 years of Microsoft's history, I was very proud of the fact that I never met with any politicians. Today, as I go around the world, I've met with many heads of state who are just fascinated with the idea of what should they do to foster the internet phenomena in their country and make sure that their human resources are able to reach out to world markets in an efficient way using this amazing capability. We actually went to Bermuda, kind of a strange place, but we thought that'd be an interesting place to go find someone and see what they thought about the state of the art, about all these ads that have got URLs in them and all these, the frenzied activity taking place. And so we found a musician down there and put together a little video with his reaction to the whole internet phenomena. So let's take a look at that. So it's happening, and really nothing's going to hold it back. But it is interesting to look at the factors that prevent it from happening overnight. One of those is the whole question about the business model for content companies. Will advertisers be willing to pay lots? Will people be willing to sign up on subscriptions? And there's a lot of great experimentation going on in this, but I think some people will hold back until they see some great success stories. As I mentioned, we're all having to think about the government now that we're in the communications era, and there are a number of issues here. Just in the United States, you've got the issue of strong encryption and what the government's trying to do to hold us back there. You've got the issue of censorship, which is a hot one right now. You even have a number of upcoming issues, like an attempt to take the internet and put it under the same regime that long-distance operators are under, which would be a major step backwards. But when you think of these problems in the United States, and just imagine that the U.S. is the best case in terms of paying attention to this and having broadly a deregulatory approach to things. And because the web is global, it's going to be a very tricky problem to make sure that government interference doesn't slow things down. There are people who think, well, the answer's simple. There should be no restrictions of any kind to what people do on the internet. And I wish it was that simple. But I imagine, just to take one scenario, that if you're a developer whose software product is saying being downloaded from a server that's in a country with no copyright laws, and you're no longer getting much income, you might wonder if a wide open approach is exactly the right way for it to be managed. And when you get to scenarios like that, it's very tricky to think, who's responsible, since you can't get back to the server level. How then is there a mechanism that makes sure that intellectual property or whatever other rules apply, that those can be done effectively? And so we're all going to put a lot of time into this, whether it's in Washington, D.C. or many other places around the world. One of the great issues that's coming up is that because the internet is so fantastic, it should be broadly available. And so kids in schools, people coming into libraries, urban or rural, rich or poor, getting that accessibility, I think, will become a priority for society in the same way that making books available did, which led to the creation of the entire library system and the focus on literacy. Now that may take some time, particularly as you go around the world, but that's another thing that I think all of us can foster and be involved with. We do need standards. We don't need too many standards. That's always a tricky problem. But I think the net has a way of coalescing around a few standards that'll make sure that's not a problem. Once again, everybody has to do their duty, whether it's committees or proposals or making sure that things are kept open in the right way. And a final problem is bandwidth. Some of the scenarios that are important require a lot more bandwidth than just the narrowband phone dial-up is able to provide. And so the question is, how do we move to the next level? With the dial-up modem, we will be able to get simultaneous voice going across that data channel, and I think that's a huge step forward. In fact, I'm going to show some scenarios that involve the use of voice that I think are very, very mainstream. So there's one more thing to do there in that narrowband world. But the big question is, how quickly can we get people up to midband, up to a level of performance 5 to 10 times faster, where still images are incredibly fast, audio is very easy to work with, and you can even start to use video data types. Our two big hopes here are the phone companies and cable companies, and ideally they both do a good job so that we can see vigorous price and investment competition for them to get in and provide those connections. In countries where cable is not as well developed, then for local access, there's really only one provider. And so there you simply have to convince the company to make the large investments and to approach it as a high volume, low price type phenomena. We're sort of stuck with ISDN a little bit where the volume's not there, so they don't bring the price down. Until we can show them the incredible demand and until they understand how to build out their capacity, I think ISDN will be a little slow. The most optimistic estimates I've seen for midband would show about 10 million people in the United States connected to midband by the year 2000. And that's subject to a lot of things having to go extremely well. Even in the cable case, where the focus of the industry is very, very clear, and their understanding of the price it takes is very clear, there's a lot of system upgrades that have to be done in order to get out there in the very large numbers. And so it'll be interesting for content developers and tool developers to think, well, there's a lot of users, the majority of users coming in narrowband, but yet you have other midband customers or people connected through corporate networks or university networks that have those higher speeds. And making content adapt appropriately to the speed is an interesting technology issue. The holy grail, of course, is broadband. Once upon a time, the phone companies told us we'd get that very rapidly, that they'd just go out there and build that. But as they stepped back and looked at the business cases, they've realized that that's not a clear winner. Although in some cases, where you have lots of density and affluence, say in Stockholm, what they've done with optic fiber, or Hong Kong, or Singapore, or a number of others, there will be urban access to broadband within the next couple of years. Well, what are some of these key standards? Well, certainly today, and this entire conference is focused on the idea of active pages, making it easy for code and new data types to get in and be an integral part of that experience. Electronic commerce is an area there's been a lot of progress. The credit card standards that Visa and MasterCard are standing behind will do a lot to move forward the amount of business done on the net. Security is a particular issue for me because about 90% of the electronic mail on the internet that appears to come from me does not come from me. And so if you get sort of an unsolicited job offer or a rude statement coming to you, you might think twice about whether that's really me out there sending that mail. There's so many people who send me mail that say, oh, thank you for visiting our site. Did you really like our site? Isn't it a wonderful site? And of course, I've never heard of the site. and I'm never quite sure what to say back. I don't want to disappoint people. Obviously, multimedia data types are key to making the experience richer. And it'd be interesting to have people guess, say 5 years from now, what percentage of pages will simply be static 2D pages versus 3D pages that you navigate around and meet other people. I think in terms of traffic, by far the majority will be 3D type pages. And that means there's a lot to be done with the hardware, with the runtime software, and certainly with the authoring tools to make that straightforward. A major milestone we have to look at is, when does the internet have quality of service guarantees so that you know that data will get from one point to another? Of course, that comes up for real-time data like audio and video, but it also comes up for corporations. For efficiency's sake, they should just get rid of all the leased lines that they've got around the world where they've built up essentially a private network. But before they're willing to do that, they have to have some assurance that there won't be traffic jams and there won't be security problems that prevent their data from getting through. And the amount of business, the amount of income that can come to the internet as corporations really say, well, this is it. This is how we'll move our data to all our branches, between ourselves and our customers, is quite dramatic. But getting quality of service standards into the backbone and then getting software standards for that will be a very, very important element. And we're involved with many others in trying to make that happen. Now, part of the unique thing that Microsoft is doing, and I hope this was illustrated very clearly in many of the demonstrations yesterday, is a strong level of integration into Windows. The idea is that when you're using local data, using remote data, it should be the same. So what we want to do is have everything that comes up on the screen use the browser. The browser will be at the center of the system. What used to be called user, the central part of Windows that does dialogues, that will be our HTML engine. And so extended HTML will be everywhere. Forms, packages, dialogues. Our help system won't be a separate exe now. It'll simply be use of the extended HTML. The editor we have built into Windows will let you compose HTML forms. That's the successor to WordPad, which we have today. And so by doing that, the browser is always in the working set. You know, that 3 meg or so that's in the operating system, that will include the HTML rendering. We want to have the unification of interface take place not only for directories and pages, which you've already seen, but also for messages, documents, the way you navigate around, find favorites, traverse links. There's no reason that as you move to what have been different storage systems, different containers, that you should see any differences there at all. And that synthesis is very important for providing ease of use. Another key point here is that this quality of service thing I talked about actually has to appear in the operating system as well. The idea of a task being able to say, I want to set aside enough bandwidth, enough CPU cycles to be able to deliver this movie or this audio, and making sure that that guarantee can be sent back so that nothing comes in and interferes. That's very important. And that's fairly deep scheduling technology that will be built into Windows. At the server level, integration is equally important. Now, part of the idea is the commonality between the client and the server, so that code can move around dynamically, so you can share common development tools, share the user interface. If an application that's running on a client wants to do printing, why shouldn't it just, instead of using client CPU cycles, just tell the server to run a version of that application up there and do that print command and completely free up the local system? Well, if it's the same operating system, there's no development involved. It's just a matter of redistributing the task for what's appropriate in a particular case. So we think this approach of common security, common object model, and in particular the distributed COM that we're giving out here at this conference, we think that's a very powerful story. To administrators who are looking at the complexity of managing usernames and all the different events that can come out of these systems, pulling that all together and letting them filter that in one rich way, we think is an important step for these networks to grow as much as they need to without creating huge overhead. If you imagine today a medium-sized business who wants to set up a server, they have to think about so many things. They have to think about what's a relational database, what's a messaging package, what's a web server, what's an admin tool. And all of those they have to buy separately, learn separately, install separately, and understanding what their various roles are and how to work with those. It's way, way too complicated. We have to have a server that's turnkey, that you buy it for your business, and messaging, customer database management, telephony integration, being able to publish catalogs, all of that, including the electronic commerce support, is simply built in, and you don't go out and learn what's inside all of those things. And so the software industry, and certainly Microsoft in particular, has a lot of integration work to do with these pieces in order to make it turnkey for every business in the world to just go out and buy a box and boom, put up their products, start entering their customers, and be in business on the web. So the breadth of opportunities here on the internet is pretty incredible. And I thought I would do a few demos today to show some of the incredible progress that's being made here. We're going to start out with a product that actually wasn't written with the internet in mind. It's Mech Warrior in the entertainment side. And I'm going to ask Kip Olson and Andy Cohen to come out and let us take a look at this. It's a Windows 95 game. And what happened was that when this game was written, they supported our Direct Play interface. And Direct Play was part of the game SDK we sent out last October. Now, in the first game SDK, Direct Play 1.0, only supported multiplayer use across the internet. And so Andy and Kip are going to give us a look at what can happen when you simply plug in the Direct Play 2.0 and see how that works with the internet.
Yeah, great. This is the game. It came out last fall, and last week we were upgrading the Direct Play interface, and we got it running over the internet. So let's just try that. I have a great job because I get to blow Andy's arms off every day.
Yeah. It usually works that way, too. It's a little dark here. I'll see if I can make it brighter. Now, we're dialed in over analog lines running over the internet. And you'll notice that even though this is highly interactive, the latency is not a real problem for this game.
So the great thing about what we did here was not that we just were able to make it play over the internet, but we're able to use the architecture of Direct Play to just slip something into an existing game and give it new capabilities. And we think going forward into the future, we'll be able to enable new gaming networks. We'll be able to have online providers like America Online plug in and be able to play games over that. But more importantly, we're going to be able to upgrade new features of gaming, like, for example, we'll be able to have game service to allow you to plug in and have 1,000-player immersive environments. We're also building what we call a lobby interface, which is a way for you to find somebody on the internet to play a game with. And that might be as simple as a chat field, but it's also going to end up being 3D environments that allow you to walk through spaces, find people, and talk to them. And you might see something like that later on today.
Okay. Well, it's great to see how people are using the Games SDK to have high-performance graphics. There's been a real focus on the entertainment community, and they've really responded well with lots of great games. So it's
yeah,
super
we look forward to a lot of great games coming out next year.
Super. Yeah, well, now let's take that concept of a meeting lobby and consider, how could that be used? Say you want to sit down and do a training session. Say you want to sit down and just socialize. Say you want to get together to discuss a product. Today, people use chat-type interfaces, but they're not very visual. You have to type in all the commands. And there's no reason it should have to be that way. And one of the companies that's been tackling this challenge of creating great meeting spaces is OnLive. And I'd like to ask Henry Nash, who's the head of the company, to come up and show us some of the progress they've made in not only creating a visual way of letting people get together, but also now bringing audio into the experience in a fantastic way. And this is not just for entertainment. This can be used for lots of great business scenarios as well. Welcome, Henry.
Hi, Bill.
So what do we got here?
Okay, what we have here is a 3D multi-point audio VML browser. We're out browsing a space on the net, and as we look around the space, it's like any other 3D space. We can move around. But the difference about this space is that there are other people there. So we're obviously embedded as an active document inside the Nashville shell, but there are actually people out there connected on the internet. So to your point about socializing, let's see how we can interact with them. Hi there.
Hi, Bill. This is Dave from OnLive. I'm here to help talk about the real-time multi-point audio today.
So you look good, Dave, but where's your body?
Well, one of the best things about cyberspace is you can decide to leave your body at home when you go online.
And is that...
Would you like me to show you about some of the ways we can navigate through 3D space?
Sure.
Well, it's really quite easy. You can use your arrow keys and essentially use your left arrow key to rotate left, your right arrow key to rotate right, or the up arrow or the down arrow to move forward and backwards. You can also go through some high-performance moves like, or you can spin.
That's pretty good. Can you show a motion?
Oh, sure. One of the best things that we have is the ability to show a wide range of motion and different avatars on screen. Let me show you what I would look like if I want to portray some graphs. So this is surprising.
Ah, pretty nice.
I really like your avatar, Bill. Henry, why don't you take us into the customize your appearance and show how the range of avatar customization that you can have.
That's pretty embarrassing. I don't know who made that one.
Well, maybe we can improve this a little by hairstyle, maybe.
I don't know.
I think that's better, and maybe maybe we can this perhaps. No?
Looks like I've got lipstick on there.
Yeah. You can also, as well as changing your appearance, you can also morph your voice to be higher or lower like a robot. You can set up a profile for information you carry with you on the net. So let's go back into the space.
So now can we hear multiple people and talk to them all at once?
All at once. And as well, one of the things that you just mentioned in the customizing your appearance is like if you have a profile, you can use that to enter an email address so people can also send you email by, say, dropping a document on your head. But let's bring one of those other people in. I think in the space we've got Randy from OnLive also. Randy, are you here with us? Hi, Bill. Hi, this is Randy.
Hey, Randy, how you doing? It's a little windy up here.
So show us some multiple talking.
Yeah, Randy, why don't you join me in a session of row your boat? I'll start out. Row, your boat, row the internet.
Don't give up your day jobs, guys.
That is.
Yeah, we haven't quite gotten these singing online jobs now. Maybe if we added a little bit of, let's see, how about some musical accompaniment? I think we've got somebody else online here. Are you with us, Mike? Yeah.
Oh, wow. We got a guitar.
That's great. That's great, folks.
Yeah, so...
Well, why don't you tell us a bit about where you're connected, by the way, on the internet?
Oh, sure. That's great. Dave, I'm just backstage, and I'm connected locally. Randy, how are you connected?
I'm at the OnLive Technologies office in Cupertino, about an hour's drive from where you are, and I'm dialed into a modem connection.
How about you, Mike?
I'm dialed in through my internet service provider, Devin Taylor.
One of the best parts about this online traveler technology is the way we've been able to meld technologies from Microsoft, like the direct 3D rendering engine and sweeper technologies that must be a well-integrated internet application, as well as the technologies from online, which let us do the real-time multi-point audio over over low bandwidth connections. We can run on a machine that's got Windows 95 on a Pentium processor with to the first floor, and it's run today. We frequently have people dialed in from Korea or Sweden or other countries like Florida.
Okay, Dave, well, I know you're going to have some more people come and join the party there in cyberspace. We'll take the volume down and just watch you play while we just perhaps talk a bit about what this means for the server side of the internet and so forth. Basically what you're seeing here is an HTTP server storing a VRML file and an NT box that is running the voice server. So this is a way in which, using NT, we can turn information sites out on the internet into community sites. The online traveler, using these technologies, lets you go out and travel the internet, visit these communities, and interact with the people once you meet them, and talk to them, exchange email, and so forth. It's really turning the internet into a way of communicating rather than just information.
And so designing a new space, will there be tools so people can do that as well?
Yeah, one of the changes we made is, this is just a regular VRML space. You can use any VRML editor out there today. You add a couple of extensions to point it at the NT server that's providing the voice services, and then that VRML space can be looked at by regular VRML browsers or by the traveler, in which case it's a community of people interacting.
And so what kind of markets are you looking at here? I suppose even a company could have people get together and do various sessions this way.
Yeah, especially with the support for 14.4 and 28K modems. Salesmen on the road can dial in and do their conferencing, distance learning, entertainment we're seeing here, going online and meeting people. As you can see, there are avatars arriving as we are in a sort of party here. We've got a nice cat arriving. So there are a whole range of applications. I think you're right that it's not just about an individual technology. It's about fundamentally changing the way people communicate on the internet.
Well, that's fantastic. Well, thanks so much for coming and showing it to us.
You're welcome.
Super. Another big thing that everybody's talking about now is the intranet. And certainly over the next couple of years, that's one of the biggest opportunities for all of us. It's very interesting that companies have made huge investments in PCs and networks to let people run productivity applications. But the investment they've made there is 90% of what they need to do great information sharing. Now, some companies are already there where they have server names that people know, and you go up and you know certain file names. But even in a technology company, that's still a little too hard for people to go out and find. And so it's been very interesting as we've started to take internet technology and use that internally at Microsoft to take the information that we've always had up on our servers, but publish that in a way that's easier to get to. Our usage of that information has gone up by a factor of 5. So I'd like to ask Jeff Kelleran to come out and just show us one example of how we're using these various home pages. We've got home pages for everything now internally, for personnel reviews, sales forecasting, and I think here we're going to see an example involving some financial data.
Okay, thanks. Well, I'm excited to have the opportunity to do this. Not so much because I'm going to be presenting new technologies that you haven't seen. In fact, a lot of this you've seen in demonstrations yesterday. But more because I think it's an interesting display of how you can mix a lot of the different technologies, office, back office, and some of the development tools to come up with a really meaningful solution. So I work in our finance group at Microsoft, and one of the big challenges is how do you deliver this vast amount of financial content to a really broad number of users? We have several thousand users that access our financial statements, that look at our revenue data, at our expense data. So how do you deliver that to them in a meaningful, easy to navigate way? So what I'm going to show you today is a scenario where if you're an executive at Microsoft, how it might feel. So here I've got an email, and what this is just a high-level summary of what's gone on. And you'll see I've got an embedded Excel sheet here. So I can get, at a high level anyway, a really quick snapshot of what's going on. Now, if that's not enough for me, I've got a link in here to our finance homepage, so I can really quickly and easily get right to the supporting content. So let's go ahead and go to the finance homepage, and that's going to bring up the browser. Now, what's really interesting about this to me is that this is really the first time that we've been able to consolidate and centralize all of this information in one place. And this is really in its infant stages right now. As this grows, especially when you think about some of the things that you've seen earlier this week, it's not a real stretch of the imagination to think that this will be the starting point for all of our financial content, not just our financial statements, but also a lot of what I call our dynamic content. So our query tools, even an SAP client, you'll all come to one place to get there as a finance person. So let's go ahead and I wanted to say something specifically about what revenue looks like in Europe, say. So I'm going to go to our financial statements here. And it's going to give me a couple different lists of reports. I can look at the list here. I'll pick our revenue summary report. And I'm going to go ahead and open that. And you'll notice that this will just open an Excel document within the browser. The user doesn't know that that's what that is, but you'll see that right here in the browser.
Tells us it's confidential.
That's right. So only top people can look at it.
Don't look too closely.
Okay, so here you'll notice that we actually use Excel pivot tables to present the data. I think it's probably one of the most undersold features probably of pivot tables, but it really turns out to be a great mechanism for delivering this kind of data for a couple reasons. One is that it's really tightly integrated with ODBC, so you can get data from any ODBC data source. And second, just the functionality to be able to filter the data and to change the dimensions of it by just dragging and dropping is really a powerful thing. It allows you to sort through huge data sets really quickly. So I said that I wanted to see something specifically about Europe. So I'm going to go to the drop down there and change it to Europe. And now I've got the information that I want. Pretty quickly and easily I've gone from a real high level financial statement down to something a lot more detailed. So now with some of the advances in the browser, though, what this allows me to do is I can pretty easily go back to where I started that list of reports by just using the navigation tools. So I click on this. It's going to ask me if I want to save the changes here. I don't want to save the changes. And now I'm back in the browser. Now, the really important thing about that for me is that as a user, my whole experience is the browser. It's not these different applications popping up and me having to track those and where is which document. My experience is really just navigating and comprehending the different content.
Well, the one thing I like about it is if I see those sales number and I don't like them, they've got the email names of everybody on here, so I can just send an email message and close that data. So I find it a very powerful tool.
Yep.
Well, thanks a lot, Jeff.
All right, thank you.
Great to see that example. I think the bottom line there is that any company who's got PCs and has connected them together really would benefit immensely. They'd get a lot more leverage out of that huge investment just by buying a little bit of extra software and coming up with the internal standards for how they want to present these pages. So a lot of the promises about PCs, that information would be at your fingertips, is now coming true by blending the productivity technology with the internet technology. So the intranet is the first stage for companies. There they don't need to worry about bandwidth. They don't need to really do anything but pull in new software. But the long-term potential is not only to share information inside the company, but to reach outside. And that's this electronic merchandising and electronic commerce. And Microsoft is working on a number of initiatives there, a media server, a commerce server, and in fact we announced a large partnership with Walmart as a lead customer for some of that technology. I've asked Pierre DeVries, who's involved in our merchant server and is working with Walmart, to come out and show us an example of what do we think shopping will look like a year from now. And what we've done is we've assumed here that you've got some kind of mid-band connection. You've got ISDN or the cable modem or a corporate LAN connection. And so we're going to show how voice and video and interaction might fit into a new shopping experience.
Thanks, Bill. So here I am on my desktop. I'm checking my mail, and I see I've got mail from quite a number of different people. I'm playing the part of somebody who's really into skiing, and there's some mail from somebody who said there's a really great review on this dynamite ski. I'll skip that, and I'll go straight to AdventureWorks. AdventureWorks is an online equipment manufacturer that I shop with a lot when I go online. And you can see that there's the beginnings of customization here. They know my name. And there is nice streaming video that gets me into the mood for shopping for winter goods. I can look at various parts of the site, and you notice that I open my mail and I get HTML. It's just part of the experience. What I'm going to do today is click on my custom catalog. Because AdventureWorks knows my profile and they've got permission to track the kinds of things I've been buying, they know what I might be interested in. And what they're suggesting today is that I might look at some parkas, because they remind me that I bought some thermal underwear earlier in the fall, and I bought some ski boots, bought some bindings. Okay, here are some parkas to look at. And I can do the other side of 3D. Rather than being inside the world, I can have the object there and I can look at it rather than being looked at. But that's not what I'm into today, so I'm just going to keep right on browsing. So here we're getting into skis, and you'll see that the advanced ski is highlighting, giving me a hint that that might be a direction I want to go in. Of course, I can go to the novice and the intermediate as well if I'm buying skis for somebody else. But today I'm going to click on that advanced ski and see what they tell me. I get all the various different skis, but I've heard about this Dynamite VA80, and I'm going to click right on that and find out more. So here we are on the page that AdventureWorks has put together for me on this ski. I can buy it immediately, it's on sale, but I want to get a little bit more information, so I can check the reviews. I can check the package prices, but in fact I've already bought a lot of things, so I'm not going to do that today. I can, in fact, with Personal Fantasy, design my own ski graphic and put it right onto the ski custom for me. But what I'm going to do today is check the technical info. What I really want to know is this the right kind of ski for me? And what AdventureWorks is doing to help me do that is giving me the up-to-date information from the manufacturer. Now, AdventureWorks doesn't really, as a provider of services, doesn't want me to go away and never come back. So they're actually doing a search on Dynamite's site, pulling down the up-to-date information and preparing that and putting it into their frame so that all the navigation tools that I'm used to using on the AdventureWorks site are there for me. So I can look at the ski and I can see it's got a fiberglass monocoque construction. And since we're talking about the future, I particularly like number 2, which is the unobtonium sidewalls. And I can do the kinds of things, I can simulate the things that I might do in the store, which is to flex the ski and see what it looks like from all sides. And at this point, I've got all the kinds of information that I can get from AdventureWorks. Now, that isn't always going to be enough. You can delve down, but not necessarily every piece of information that everybody wants will be there, so you want to talk to a real person. So what I'm going to show you now is a simulation of the kind of thing that you can do with a mid-band connection with quality of service, so that I can click on this service representative and have a video conversation. I can see her, but she can't see me. She can just listen to me.
AdventureWorks.
Oh, hi. I'm looking at these skis, trying to decide if they're right for me.
Okay, and you're looking at the Dynamite All-Terrains. Those are great skis. And you've already checked the technical data. Where do you like to ski?
Oh, Crystal Mountain, Whistler, the Cascades.
The Northwest. Okay, let me pull up my map. All right, they seem to be most popular where the snow is wet, not too icy, such as the Cascades. And most of the folks in BC seem to really enjoy them as well.
Okay, that's great. I think I'll go with them.
Great. Enjoy your new skis. Is there anything else I can help you with?
No, that's all. Thanks very much.
Thanks for calling.
So, I've got the information I've needed. I've spoken to a real human being to get the assurance that I wanted. And I'm now ready to press this wonderful order button. And of course, like any good merchant, AdventureWorks knows that I'm buying skis and is suggesting that I might want some bindings to go with those. Today I'll decline politely, since I've already bought some earlier in the fall. And here I have the shopping cart. Now, the shopping experience that AdventureWorks has given me will be different to that of another merchant, but there are some things that I want to have really constant, so that when I'm shopping, these things are the same no matter where I go. So this is a standard shopping cart that Microsoft is designing that I will be able to find anywhere I go. I can see the item that I'm going to buy. Shipping and tax is calculated automatically. And I'm just going to press Buy Now, enter my password. My Visa is already set up. I can change that if I want to at this point, but I'm not going to do that. And I'm going to pay right now. What happens is that the transaction gets set up for me. AdventureWorks merchant server creates a tracking number which is stored on my client, so that if I want to go away and search for the item a few days from now to find out where it is, I can do that. So I'm done with that. And in fact, here's a little dialog box that says there's good news about my AdventureWorks account. Do I want to know about it? And why not? And I'm told, congratulations, I now have 3,500 purchase points, and this might just entice me to go and do a little bit more shopping. Back to you.
That's great. It looks like shopping will be more efficient, so we'll all have more time for programming. Super. Thanks, Per. Well, the big question here is what is the opportunity for all of us? I'd put it at the top of the list here, volume. The economics of the software business are very, very volume dependent. In fact, if you just look at the operating system business, if we only sold 30 or 40 million operating systems a year, we'd lose money. We couldn't afford the R&D that we spend. But because we sell more than 60 million, it's a pretty fantastic business to be in. And that's just one example of where volume comes in and really has an impact. So we believe that with the internet, the number of people using software in a very broad sense will go up very dramatically. Now, for a software company, it's a chance to stay in contact with customers, let them have information, a chance to support them better. Just imagine, compare what we have today when people call up on the phone and try and describe what's going on with their computer versus just connecting through the internet. You can see their screen, guide them along. You can get all the context of what they've been doing electronically if they want to let you do that. And so you can shorten that technical support and do a far, far better job. For many software companies, that's a big deal. We spend over $500 million a year on our customer support. And we don't expect to be able to reduce that, but we do expect to be able to do it more efficiently and therefore do an even better job. Software distribution, a lot of that will move onto the internet. Certainly demo software, smaller software. CD is also a very efficient distribution vehicle. So between those two, we're a lot better off than where we were with just floppy disks only a few years ago. Certainly there'll be a huge market for component software. The business there we expect to be about 10 times bigger 3 years from now than it is today. And a lot of that is the so-called active controls. All these people who are doing content work, they are not programmers. They don't want to know about programming languages or any of these things. They simply want a palette of things that they choose from and drag and drop those into their pages to create that interactive presentation. And so they're counting on all of us to build rich libraries that span all the different scenarios, whether it's browsing a house plan or looking at a shopping cart or trying to plan a schedule, looking at maps. Every data type that exists in the real world, we need to create great controls for and make those available to the amazing volume of authors that are going to be out there. Certainly there's room for lots of new applications, and there's room for new versions of existing applications. For us, that means going back and looking at everything like Office and saying, how can it be better in this environment? I'd also say that beyond the product business, there will be far more demand for people who understand the internet and setting up software applications on it than will be available worldwide for at least the next decade. So we're sitting at the center point and companies who have that service aspect will be doing extremely well, just like the product companies. I wanted to make it clear how big a bet we're making in this area. Everything Microsoft's doing now is tied in with the internet. I've talked about the client software and the very rapid evolution there. The server software, lots of new additions there on an integrated basis. The family of tools is quite broad. Sometimes when people talk about pages, they're talking about something simple that's just text, and sometimes they're talking about a custom-built application that might have millions of lines of code behind it. And so the spectrum there really demands quite a range of development tools, all the way from standard productivity tools up to C compilers. Any language that people want to use, we're going to be there to support, and any level of sophistication they want in the tool, certainly we and third parties will have what's required there. Now, we're also doing some things to build internet sites, to bet on this content business. Now, that's very similar to the bet we made with Windows on building spreadsheets and word processors. Now, the content business will always be 100 times more fragmented than, say, productivity software. But we see a good opportunity, and we think getting out there and being a pioneer in using this technology will help us to do better on the other pieces and in some cases actually show the way. So we've got the Microsoft Network. It's now just a community on the internet. There's two ways to sign up. You can sign up where we include our access, and so it's got the phone number and the connectivity. We're at over 850,000 users just in the 7 months that we've been up, and so it's actually faster than we would have expected. A lot of work going on to build broader availability of the connectivity throughout the world, and huge investment going into the content. The focus here is on HTML and exploitation of these active technologies you've heard about, so we'll make this be a showcase. MSN, our content club, is part of what we're doing, but we have a very large interactive media division that's looking at a number of things. Some of these will be purely advertiser supported. Some of them will be transaction supported. And we think the opportunity to get out there, in some cases by ourselves and in some cases in partnerships, is pretty fantastic. Some of the big partnerships we've done include the work we're doing with the DreamWorks Studio, which is building new interactive titles and taking the work they do in other media and bringing that into this interactive world, both CD-ROM and the internet. Our partnership with NBC is a very big one for us. It involves a 24-hour cable channel, a lot like CNN, but with a bit of a different twist, and connected in with the internet site. So those two will be referring to each other, cross-promoting each other, and all the programming is done for the cable channel and the internet site as one overall strategy. We will be taking our current CD-ROM titles, like our Encarta Encyclopedia, and making it available through the web. Also, because it's an encyclopedia, in a sense, it's like a front end. Any of the articles you see, there'll be links off to all the different sites on the internet where there's up-to-date information about that topic. And so the equivalent of applications here is content, and we'll be one of many, many companies that are doing our best there and showing that we really believe in this by making huge investments, some of which won't pay off for a long, long time. Now, I think it's critical to keep in mind that everything is improving here. You can't think of the PC itself as static. You know, the PC that we were all proud known for 5 years ago, today I don't think any of us would be very satisfied with. And the pace of innovation, if anything, is faster today than in the past. Whether it's the size of storage, it's going to be hard to buy a PC with less than a gigabyte a year from now, even a $900 PC. Faster processors, I'm quite impressed with the work that Intel and its competitors are doing, bringing us products like Pentium Pro. That's a huge step forward for multi-processor system with the very high clock rates. that Intel's got there, and we're certainly in partnership with Intel, building compilers, building in extensions for MMX, which are their multimedia instructions, that I think is a great initiative by Intel. I believe that a lot of PCs will have smart card readers. Part of the security problem will involve smart cards. In the United States, we won't hand them out to every person, so it'll have to be the credit card companies. But in some countries, they're just becoming a standard thing that everybody in the country will have. The hardware for handwriting has not been popular to date, but I still believe that's a ripe area. I think people coming to a meeting like this one, even 3 or 4 years from now, will all be bringing a PC and able to work on that in taking notes. Video and graphics, the PC, the room for improvement is pretty incredible here. Not only moving up to 3D and higher resolutions, but moving up to a whole new way of thinking about the graphics subsystem. And of course, advances in screen technology make a big difference in terms of what types of documents you're willing to view electronically versus doing that on paper. Now, we've got a lot of things we've got to do in the operating system. I broke this into 2 slides, one that I call improvements. These are pretty basic things. In some cases, you might even say remedial things that are crucial. We've got to make the system very solid so that you don't end up with device drivers that break things, or the fragility we have in terms of configurations. And we get over 1 million calls a week from people. We log all those calls, and we understand very well where it is we need to go in the architecture. The PC is getting better in this respect, but it's nowhere near as good as it needs to be. Automatic configuration is critical. Plug and play was a step in that direction, but the Simply Interactive PC, SIPC effort that we're putting a lot into goes a big step further in that. We think it's got to be easy to upgrade systems and applications. Many software companies have huge installed bases, and if you go out and talk to those users and say, why aren't you buying the new versions? It's because of the complexity. As we make it as easy as downloading a new browser to get the new application, to get the new operating system, those upgrade rates will be dramatically higher, and that's very, very doable. The always-on communication where you don't think about boot time, application startup, that's got to be done, because when you want to get information on the internet, you just want to walk over to the PC and get it. You don't want to wait for that to happen. One particular point I put down here is the family strategy. Of course, NT is positioned as a high-end superset of Windows 95, but in the last revision, we didn't synchronize the shipment schedules, and there were some things that were in Windows 95 that were not in the high-end member of the family, Windows NT. Well, particularly now, with memory prices really starting to come down and Windows NT being bundled on Pentium Pro systems, the idea of making this family strategy very clear-cut, real subset, superset relationship, because over the next several years, whether it's 2 years, 3 years, 4 years, NT will become a huge part of that desktop mix. It's very important that we're delivering totally on that family strategy. At the same time we're doing those improvements, we're also going to be doing a lot of very innovative things. Unified storage. This is the holy grail of Cairo, the so-called object file system. Advanced directory that deals not just with user objects, but with objects of all types. User profiling is something we got a little bit of a glimpse of in our shopping scenario there. I think this will be very deep technology, probably based on Bayesian inference, where you have a model of the user and you track what they're doing. And that allows these agent scenarios where you help the user, where you guide them, show them new things they might be interested in. That allows that to work. It's a fairly deep set of technologies that should be shared across all applications, and therefore we're looking at that as a piece of the future operating system. Likewise, speech recognition and natural language parsing. Those aren't things that should be built into every application. You know, if you go 10 years out, I would say that a lot of web navigation, a very high percentage, but will be voice-driven type navigation. And so we've got to get into these clients system that is very rich in being able to do that with a lot of accuracy. In parallel with this, we will have more variety of devices hooked up. Now here it's a little unclear what the critical mass will be. And it's important to remember the PC has a large installed base, over 200 million systems in active use, and over 60 million sold every year. And even, with that staying at 60 million, those numbers are pretty overwhelming. And that's where people will be focusing their content. In order for another one of these design points to get to critical mass, it's tough because you've got to get authoring attention. The kind of page you want to put up on a TV is a little bit different than what you want to put up on a high-resolution screen. I think the TV flavor will come into this, not as a substitute for the PC, but just another place you can go in and browse certain types of content. Likewise, the portable device, the PDA or wallet PC, that's an area where we're making huge investments, and we're actually taking a subset of Windows, a portable subset of Windows, and building it into those devices. Now, there are people who even say that for high-resolution screen devices, there may be more variety. I certainly agree with that. Diskless PC will start to be important for people who have high bandwidth connections. It's not going to work when you're connected at 28.8 or even most of these mid-band connections to be doing web browsing, because the amount of code you use as you not only run the browser, but go to things like Shockwave or Acrobat or Real Audio or the dozens of object types that are out there, you're actually using more code when you browse the internet than the large Windows applications today. You can't do it very well in a 4 megabyte system, and in some scenarios even 8 megabytes is fairly difficult. So it's not the case that web browsing is a low-end application. It's a very high-end application. And in fact, all the things we're talking about here and making these pages richer with media and controls will simply further that. And so when we think about how will PC configurations change, will diskless PCs finally take off? Will people choose to buy PCs at lower price points? This is all very relevant. There have been people promoting $700 and $800 PCs. In fact, you can buy a 486 DX4 machine for about $800. To date, the marketplace hasn't pulled those in. The PC market is very competitive. I do believe over time there will be more divergence in PC configurations. People who take the innovation and use it to drive the price point instead of just leaving the price point steady and driving the power of the machine. When you think about these new configurations, though, it's important to think out what you're leaving out. Are you leaving out the screen, or the keyboard, or the mouse? Are you leaving out the processor? There's certainly no magic in processors. The cheapest processors are where the volume is at any level of performance. That's why high performance, things like Pentium and Pentium Pro are the most competitive. And if you want to move down a notch, there's lots of people who have got 486s that aren't finding much volume today. And so the different elements that make up a PC, if you were going to build a PC just to do browsing, you couldn't leave too much out of it. You probably wouldn't leave out sound. You probably wouldn't leave out the network connection. Now, there's a lot that can be done to make the operating system easier, to make these kind of scenarios for the person who's primarily doing browsing simple the way it should be. So we've got some work to do, but I would suggest that really the PC can be configured in ways to meet these scenarios, and certainly we're very focused on making sure the software is there to do that right. Well, yesterday was a very exciting day for many, many announcements. To me, the most important announcement yesterday was the one we made with America Online. The reason for that is that in terms of promoting all these great technologies that are being discussed here, we've got to get them into widespread use. We get up every morning and we think about browser share. And we've got a lot of creative ideas to drive that forward. But the partnership we've got with AOL is certainly a centerpiece of that activity. The browser we're doing with AOL will be their standard browser for their AOL members. It'll be integrated. They're going to do great things taking advantage of the active technologies, and the integration will be very seamless here. And I'm very excited that today Steve Case agreed to fly out and talk to you a little bit about how he sees this partnership in the industry. So let's welcome Steve Case, the chairman of AOL, onto the stage. Hey, Steve.
When we started America Online over a decade ago, we believed in the possibilities of a new medium that someday would reach tens of millions of people and really change the way people get information and communicate with others and buy products and learn new things. And we've made progress, particularly in the last couple of years, at AOL, going from 500,000 members to now over 5 million members. And I think the reason for that is we've really focused on consumers and tried to create services that were easy to use and useful and fun and affordable. And also, I think we've been pretty pragmatic in using technology, recognizing what consumers have and building for that. For example, as Bill mentioned earlier, this is still a narrowband world. Most people have 14.4 modems. It will slowly move to 28, and really optimizing for the world that exists is really quite important. And some of the things we do with compression and caching help accomplish that. But the final and probably the most important reason we think we've had the success we've had, and hopefully we'll continue to have, is we've had a strategy of working with lots of partners and really building a tapestry of alliances and working together with a lot of companies to try to build this medium. And in the last few days, we announced a number of alliances, particularly technology alliances, with Microsoft and Netscape and Sun and others. And I just want to talk briefly about that. There's been a lot of confusion about what we've done because there's been so many announcements, and I thought take a moment just to provide some clarity. Bill's already covered some of the key points, but I'll just be brief. Internet Explorer, the Microsoft technology, the ActiveX platform, will be our standard technology for our AOL brand, which will go out to 5 million customers. When we ship out disks, we'll be shipping it out with the Internet Explorer technology. We'll provide Netscape as an option to AOL customers. And the reverse is true for our new GNN brand, where we'll build Netscape Navigator and as a standard and provide Microsoft as the option. And Java will build into both AOL, so you can click on an AOL form and launch a Java applet, as well as make it an extension of our web strategy. The reason we're working with Microsoft is because we're really quite impressed with the technology, and I think as you've seen in the last day or two, you probably are impressed as well, and also impressed by the kind of new pragmatism at Microsoft, trying to figure out ways to move forward and work together as a united industry to move this industry and move this medium into the mainstream. The reality is only 11% of households subscribe to any online or internet anything, and 89% are sitting on the sidelines kind of saying, why bother? So the opportunity is to partner with companies to figure out a way to reach that mainstream audience. And it's not just about partnering with big companies, Microsoft, AOL getting together. It's also about reaching out to lots of creative minds and entrepreneurs to really figure out how to leverage their innovation. And many of you in the room, I think, are going to play a central role in doing that. So I'm pleased today to announce a new program at AOL, an expansion of our greenhouse effort to include software developers. As many of you know, about a year ago, we launched a content greenhouse, and over the past year, we funded dozens of startups, put millions of dollars to work trying to really fund innovation in this new medium. And a few months ago, we expanded that to include a software greenhouse for AOL applications. And today, we're expanding that to support internet developers. If you're creating innovative internet applications, we want to talk to you to provide capital. And we also want to commit our distribution and marketing cloud to take their ideas to 5 million people. And we think it's really going to be the mix of funding and distribution that's going to unlock the power of this new medium. Just creating a website or creating an application and sticking it out on the internet and hoping people will somehow serendipitously find it will probably not be as successful in the long run as figuring out a way to get plugged into large audiences such as what we've got with AOL. The goal remains the same, to try to create a new medium to reach tens of millions of people and really take this concept of online services and all the potential of these online services to mainstream, to a mainstream audience. And we're looking forward to working with technology partners such as Microsoft and hopefully many of you to make this new medium all it can be. Thank you.
Well, thanks a lot, Steve.
Thank you.
That Steve made there is the growth opportunity in front of us. You know, although every day we're out there surfing, most of the people, even in the U.S., have not, and they've got it's an opportunity to bring everybody in, and what we're doing with AOL will foster that in a major way. So a few key points. This should be a very upbeat industry. The internet is an amazing opportunity for great software. It'll be intensely competitive, but room for lots and lots of winners. If there's one thing you walk away from this conference with, it should be that we're hardcore about the internet, with all the positive connotations that implies. And finally, this communications revolution, as we're swept up in the day-to-day activity here, it's easy to forget what this can mean broadly. And it is fun from time to time to go out to schools and see kids starting to use this, or to go to medical researchers and find out how it's facilitating their work to cure diseases, and to see all the amazing ways that this is pulling together. And so there is no better business than the software business, and it's great to have you all here. Thank you.
Okay, we took several hundreds and hundreds of questions, and we filtered through them last night, and we tried to come up with questions of different categories that were most popular. One of the most popular questions was, when will Microsoft have majority browser market share?
It's a good question. We don't, as we've been in situations like this, whether it's word processing or spreadsheet or file sharing servers, predicting specific dates hasn't been key to it. I do think, it is certainly our goal to achieve that. We're going to be doing a lot of creative things on the marketing side and technical side. Anybody here who has technology that can make a browser better, let us know. We're in the market for anything that people have there, because we see the evolution being very rapid. And so we do expect our share, which is fairly low today, to be very significant over the next year, certainly to the point that people will be testing against us and exploiting what we've got, and then that'll start a positive feedback loop. So this is the thing we think about all the time.
Okay, there were lots of questions about tools. For example, which tool should I use for site development? Should it be Front Page or Internet Studio or Jakarta, and just in general our tools positioning?
Well, of course, when somebody comes in to use the site, they won't know what tools were used. And for most sites, it will be a variety of tools. Now, managing this web document type, making sure all your links are good, being able to preserve the different versions, letting people annotate things as they come along. This really does require a very sophisticated set of tools. For site management, we've got our Front Page product. For authoring individual pages, we have a lot of choices. Now, all of those choices are built around the single set of extensions we're doing to HTML and these active controls. One of the choices people have to make is between Front Page and Internet Studio. Internet Studio is sort of the equivalent of a desktop publishing package. It really gives you incredible control over the different elements, the kerning, the layout, and those things, whereas Front Page is more analogous to the Microsoft Word there, where wizards guide you through all the common scenarios, and there's some tight integration. And so to really make sure the space is covered, there will be some overlap in the tools, but you can go back and forth very easily. If you're using one, you want to switch to the other, all those file formats are interchangeable.
Okay, we're going to move into another category. There were several questions about bandwidth. Specifically this question, the biggest crisis we all face is whether the internet backbone will be able to support all these millions of new users with streaming audio and video, etc. Can you comment on what efforts you think are being taken to enhance the internet backbone to avoid this crisis?
Well, the backbone is not a technological problem. That is, the improvements that are made in fiber data rates and switching costs are even faster than the Moore's Law rate of improvement that we've all been used to in the PC industry. And there is a tiny bit of a business model problem to make sure that the on-ramp fees that are all the revenue for that connectivity business, that those are set properly and funneled to the people who make the backbone. it is, for economists, it's very interesting that you've got a pricing model here that's not based on usage. It's just based on the on-ramp. And of course, that's very different than the voice telephony network, where usage, both time and distance, drive pricing, and therefore there's a more direct feedback loop to where investment should be made to build capacity. I think because of the rapid innovation, the business model problem won't be difficult. And the backbone is the easiest part, because there's where you get the big economies of scale. The hard part in this business is local access. It's that last mile, particularly when you're talking about connecting up to homes. And there we have to hope that either breakthroughs in wireless or satellite technology, or intense competition between the two local access providers, the phone and cable companies, will get the prices for that down and make that very effective. If there's any place there's a question, which is will play out a little differently from country to country, it's more in the local than in the backbone.
Okay, the next category of questions is really about Windows platform and release schedule. We did take one question from the M-Bone. We're live broadcasting over the M-Bone, and one of the viewers asked, when is Windows NT 4.0 shipping? And I can quickly answer that, and that's this summer.
That's a very safe prediction.
The next question was specifically in the corporate space. Yesterday, during the Nashville demo, we did a demo of the SMTP POP3 based mail client and browsing news groups. The question is, how will Exchange public folders fit in with this?
Well, the client, the mail client that we're going to build in to the Internet Explorer, and therefore into the operating system, won't be as rich as the client that comes with Exchange. However, it will support bulletin boarding with NNTP and, of course, standard SMTP mail. So the Exchange client will be a strict superset of that. We will have, as a feature of Exchange, the ability to connect through an arbitrary browser and just use standard internet authentication and be able to look at public folders. And so you won't even have to have the Exchange client to be able to browse those public folders. That's part of what we call Exchange 4.1. For anybody who's using the mail client built into Windows, you'll get most of the features of Exchange, but for people who buy Exchange Server, they also get a richer client that has more capabilities in terms of the rich views on the public folders.
Okay. A real popular question was, how did you convince Steve Jobs to address the conference? How much did we pay him?
Well, Steve's fairly unpredictable. We had no idea what he was going to say, so it was partly our willingness to take risk that helped us out there. You know, Steve's done a lot of great things for this industry, and certainly one of the most fun eras for me was working with Steve on the Macintosh, which was a pioneer for graphical interface. And so we were just very excited when Steve decided to put web objects on NT and chose to come here and talk about it.
Okay. The last category of questions centered around our developer support. Specifically, when will Microsoft product support be moved to internet support?
Well, for most of the information we're providing, we're putting that out on the internet today. What we haven't had is the ability to have special forums for our beta test activities. And so we've continued to focus on CompuServe there. Over time, over the next year, a lot of that will move into MSN. And so you have a mix. For the private forum things, we'll administer that through MSN over time. For the things that don't require the private forums, we'll make sure it's out there on the internet. Already, all the material that's being presented at this conference and all the things we have relative to the internet, including our betas, which for our internet products, we do the broad betas where it's just anybody can come in and get it, and the overload on our servers the day we publish those things is pretty incredible. We've had to get a lot smarter about getting them replicated out and around the net so we don't get a repeat of what we have with the Internet Information Server, where we were overloaded for many, many days. But our whole goal here is to get all the information out, and so if there's anything you think we're holding back, let us know, because a openness is how we're going to succeed in all of this.
I think I should have stretched a little bit, though, before I did some of those games. I'm a little sore. This morning, I have only a couple of things to say. One of them is that bad spammers bad, and those of you who have been spamming know who you are. We have a few fun conference facts to start off the day with. 33,000 cans of soda have been consumed. 25,000 bottles of beer. And we didn't even have beer at the breaks, so that's pretty amazing. 15,000 bags of chips. I guess there was only one chip in each bag. 10,000 granola bars. 16,000 bottles of juice. A lot of coffee. 10,000 bananas. 5,000 apples, more monkeys than, and 16,038 feet of net cable. This morning, we are happy to have Douglas Adams bringing us our keynote this morning. He's the author of Hitchhiker Guide to the Galaxy and the Dirk Gently series. We will be giving away one of the digital laptops at the end of Douglas's keynote this morning. And then Doug Henrich, Director of Developer Relations at Microsoft, will come out and he will talk about the developer program that we have and how you can stay up to date on all of the, when the SDKs are released and other things that we have going for development. And at the end of Doug Henrich's talk, we will also give away another laptop. So let's see, the only other thing is just to make sure that, I know I've said this several times, but just to make sure everybody knows, there are the 2 Java sessions today, one at 10 and one at 2 o'clock. And so anyway, with no further ado, I'd like to bring out Douglas Adams.
Hi, I hope that was the right time to come on. Actually, we couldn't hear the sound very well backstage, so I was just waiting for an awkward pause. Just wanted to get an idea about what Microsoft developers actually look like. And I also want to have a little bit of a wander around, in fact, because actually you can tell this is a Microsoft conference because there's a clock down here which is telling me to the second how many minutes I've got left of talking. And it's going to be a bit of a problem, you see, because I'm kind of one of these unpredictable sort of creative kind of wild Macintosh kind of guys, and so it's going to be so we're just going to have to see how it goes. I'm going to try and keep to the right time. One of the problems with my speeches is they tend to be rather digressive, and it's only right at the very, very end that I try and wrap it all up and you get some idea about what it was I was actually talking about. So I may or may not get to the end. If I don't get to the end, maybe we should have a little sort of contest on the internet. I'll give you my email address, and you can send me little notes about what you think it was I was talking about and what you thought I was going to say at the end. And there will be a very, 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 very tiny little prize for whoever gets it right. Or, of course, I might finish early, in which case we shall have to have some questions. First of all, I need to pace around a little bit. I've got a bit of jet lag, and it's one of those days when you sort of wake up at 1 o'clock in the morning. But I also like to I tend to like to wander around a great deal when I'm talking anyway. There's a friend of mine who was at Trinity College Dublin a few years ago, and he was studying psychology. And he was going to a regular series of lectures given by a guy who was lecturing on Pavlov and the conditioned response. And this guy was a great pacer. He walked up and down in front of the class, left and right, left and right. And after a while, all the members of the class conspired together, so that every time he got to the left-hand end of his perambulation, they all looked bright and alert and intelligent and asked bright, intelligent questions. And every time he got to the right-hand end of his walk, they all fell asleep. So by the end of the course, they'd got him permanently holed up on the left-hand end. They'd put him on a kind of virtual slope. I don't know, history doesn't relate what happened to all those students, but I feel they should have just got a first in that paper. When virtual worlds and real worlds collide, you can have some alarming things happening. I was told a story the other day about some fighter planes that apparently were designed entirely, I think it was the F-16, but I could be wrong, I'm not an expert in fighter planes. It was designed entirely in the computer, tested in the computer, flight tested, everything was done in the computer to begin with, and eventually they were built, and the machine worked perfectly. It was a wonderful, wonderful aircraft. And then one day, a flight of 4 of them were out in the Pacific going through some maneuvers, and they were all flying in line, and suddenly the one right in front, for no reason at all, flipped over. And the one a couple of minutes behind him, or just a few seconds behind him, thought, what's going on? What's happened to this guy? And a moment later, he flipped over. So the guy behind them says, what's happening? These guys are going crazy. Why is everybody flipping over? And a moment later, his plane flipped over. All 4 flipped over. And it turned out they'd just done, in the real world, something that they'd never done in the virtual world in this plane, which was fly over the equator. And in the navigation systems, there was a sign error. One of the things that the virtual world and the real world has in common is that there is an awful lot of data out there. There is an enormous amount of data out there. How do we make sense of it? Well, largely by ignoring most of it and making a model for ourselves out of the rest. We do ignore an awful lot of it. We have to, because there's so much. There's a story I was told the other day about a dolphin research establishment, and they just got a new dolphin that was just joining the establishment, so they were running a few tests to see if they'd got a good dolphin, a bright, intelligent dolphin. They tried a few little simple little learning tests. They encouraged it to jump out of the water, make a noise, and if it made the noise, it got a fish. Very, very simple, very straightforward. The dolphin got it straight away. But they carried on the test just to sort of see if it could keep on doing it. And suddenly the dolphin began to seem to sort of drift from its purpose, drift from what it was being told to do. And every time it jumped out, it didn't necessarily make the noise that it had been asked to make. And it would make a different kind of noise, or make a quieter noise, or a louder noise, or a deeper noise. And then it was, and so they're getting a little bit crazy, because sometimes it wouldn't even make a noise at all. So it would jump out of the water, not make a noise, and not get a fish. So I think this is a stupid dolphin. What is going on? We thought we thought it was meant to be an intelligent creature. So anyway, they abandoned the experiment. A little bit later in that evening, one of them was playing a tape they'd made and playing it through an oscilloscope, and suddenly noticed what was happening, which was that, in fact, the dolphin was making a noise every single time it jumped out of the pool, but sometimes it lay above or below our hearing range. And the notes were going up and they were going down, they were getting louder and they're getting quieter, and he suddenly realized what was happening. We thought that we were training the dolphin to jump out of the water, make a noise and get a fish, but what the dolphin was doing was calibrating our hearing range. There's more data out there than we respond to. It's another experiment I was told about recently. I think I read about it in New Scientist. A subject was put in front of a computer screen, and there were 2 images for the computer screen, one of which was the speech, the text of "to be or not to be," the speech from Hamlet, and the other was just a page of complete gibberish, meaningless twaddle and gibberish. It was, I don't know what it was. It was probably a page of the user manual from Word 6. But both images were stored in the memory for the screen, and what was shown there most of the time was the page of complete gibberish. But stored, as I say, in a buffer behind it was the text of to be or not to be. The subject was put in front of a computer screen and had this kind of helmet on, which had sensors trained on the eyeballs. Now, you may or may not know that when the eyeball moves, it doesn't move smoothly. It moves in tiny little jumps from one point to another. And the jumps can be measured ballistically. If you know, if you have a sufficiently accurate measuring equipment, then you can see from the speed and direction with which the eyeball sets off on one of its little jumps where it's going to. So, what happened in this experiment was that as the sensor detected where the eyeball was going to, it substituted just at that one little spot on the screen the appropriate word from to be or not to be. So from the point of view of anybody else looking at the screen, it seemed to be full of gibberish, but from the point of view of the person who was wearing the device, all they ever saw was the text of to be or not to be. And not only was that all they ever saw, but they had no idea that there was anything else on the screen to see. Now, what that shows us is that not only do we take a small amount of data from the world and create a model, but the model is persistent. The model actually exists in our head, and we just take tiny little bits of data and update the model that we keep in our head. As you probably know, we have rather odd feature to our eye. Well, I guess it's not a feature, it's a bug, which is that the optic nerve comes in right at the back of the eyeball. And where it comes in, there are no light-sensitive rods. So whatever light falls on that tiny little patch of the eyeball, or the back of the eyeball, will not respond. So we have a tiny little spot in each eye that does not respond to light. Now, if you close one eye or the other, you are not aware of seeing a black spot anywhere. But if you train yourself, you can actually find it. There are little tricks you can do whereby you sort of move your eye along a line, and you've got a little thing, a P or something, just at the point where and you're trying to maneuver your blind spot over the P, and the P suddenly just winks out of existence. You don't see a black hole; you just no longer see the P anymore. The reason we don't see a black hole is why would our brain tell us there's a black hole there? We just have a model in our mind. Charles II actually used to have an interesting little trick with this. And it was, if you were a member of Charles II's court, you always knew you were in trouble if you found that he was looking at you like this. Because it meant he was trying to see what you looked like without your head on. So we keep a model of the world in our head, and we use the incoming data just to update it. Now let me tell you a little story about something that happened to me a while ago. One or two of you, if you've ever heard me speak before, might have heard me tell this story before, but I'm quite keen to keep on telling it because this is a story that's kind of acquired the status of an urban myth. But you know what the thing about urban myths are, that they're always assumed never actually to have happened. You always hear people saying, this happened to my wife's brother's sister's first cousin. But in this case, it isn't a myth because it did actually happen to somebody, and the person to whom it happened was, in fact, me. A few years ago, I was on I was catching a train from Cambridge to London. And I arrived at the train station a little early. I was about 20 minutes early. I'd got the time of the train wrong. Well, actually, what is more likely is that British Rail had got the time of the train wrong, but never mind. And I went and got myself a newspaper. I was going to do the crossword. And I went to the buffet, and I got myself a cup of coffee and a packet of biscuits. Oh, excuse me, I have to say cookies on this side of the Atlantic. But if you just sort of put in a little sort of search and replace thing in your brain, if you hear me say biscuits, just think cookies, okay? So I went and sat at a table in the buffet. I want you to picture the scene. Here I was sitting at a table, and here is a newspaper, cup of coffee, packet of biscuits, cookies. And there's a guy sitting opposite me. Perfectly ordinary looking guy sitting there in a business suit, briefcase. Didn't look as if he was about to do anything weird. What he did was this. He leant across the table, picked up the packet of biscuits, tore it open, took one out, and ate it. Now, this is the sort of thing I have to tell you that the British are very bad at coping with. There is nothing in our entire culture or upbringing that trains you to deal with someone who steals one of your biscuits. Now, you know what would happen if this was New York. Somebody would end up dead pretty quickly. But in the end, I did what any red-blooded Englishman would do under the circumstances, and I ignored it. Stared at the newspaper, tried to do one of the clues in the crossword, couldn't. Took a sip of coffee, took a deep breath, and thought, well, I'd better just go for one of my biscuits. And I leant across and I took one, trying hard not to notice that it was somehow mysteriously open. And a moment or two passed, and he did it again. He took another biscuit. And having not said anything the first time, it was somehow even more difficult to sort of raise the matter the second time. Excuse me, I couldn't help but notice. I mean, he said, it doesn't work. So again, I ignored it and I leant across and I took another one. And our eyes met just for a moment. And then we both looked away. But there's a little tension building up over the table at this point. And between us, we got through the whole packet of biscuits this way. He took one, I took one, he took one. And I say whole packet, when there are only about 6, I think, or 6 or 8. But it seemed like a lifetime of cookies we were getting through at this point. So eventually, we get to the end of the packet. He stands up and goes away. And I sit back and breathe a sigh of relief. A few minutes later, my train is called. So I toss back the last of my coffee, stand up, pick up the newspaper, and underneath the newspaper are my biscuits. The nice thing I guess about that story is somewhere in England there is this guy who's probably been wandering around the country for years telling this exact same story, but he hasn't got the punchline. But the point of this story is that sometimes you're using the incoming data to update a model that is intrinsically faulty. Archaeology, I'm told, is like that. It's funny, there are all sorts of sciences, archaeology, anthropology, paleontology, which started out as the domain of gentlemen enthusiasts in the 19th century. Schliemann, who went to Troy, Arthur Evans, who went to Knossos. And they took with them, in their minds, they already had ideas of what they wanted to find. Arthur Evans, going to Knossos, particularly had this image of a wonderful, brilliant, enlightened, pre-Greek Minoan culture. And every piece of data that he found, he basically bent to fit into that model. There's a wonderful book I came across recently, I don't know if it's still in print, called The Secret of Crete by a German geologist called Hans Wunderlich. And he was an amateur archaeologist. He'd read a lot of the debates that went on and on about what had happened to Knossos, what had brought about its downfall. Was it destroyed by fire when the volcano at Santorini went up? So one of the issues was it destroyed by fire? And as I say, early archaeologists really weren't scientists at all. They just went in with a nice idea and found whatever data fitted the idea they already had. When Hans Wunderlich arrived there, just as a tourist, he just bought his ticket and he walked in, and he noticed immediately, just as a geologist, as a scientist, that it could not possibly have been destroyed by fire, because the stonework that was used for the walls and the floors, which had been described hitherto as being alabaster, was in fact no such thing. And you could tell that it wasn't alabaster, but actually a form of gypsum that has a particular kind of mineral deposit veined into it, which gives it the same lustrous sheen as alabaster, but is much, much softer and much easier to work than alabaster. So if you don't want that hardness and firmness of alabaster, then you'll go for this gypsum instead. And the way you tell the difference is you run your fingernail along it. And if you scratch it, it's gypsum. If you don't, it's alabaster. But the thing about this particular type of alabaster, this particular kind of gypsum, is if it gets raised above a certain temperature, all the mineral deposits that give it its sheen will leach out of it. And that hadn't happened, so ipso facto, clearly it wasn't destroyed by fire. He then thought, well, it's very funny that it's been made of this very soft material, including the floors, because the floors have obviously now been very badly worn away. But when the excavation was started at the beginning of the century, I think it was in 1913, the floors weren't worn away. So this is a busy, bustling city where the floors had been made of soft gypsum, and they weren't worn away at all until modern times. That didn't seem to make sense. And he eventually went back to all the original data and came up with a completely new picture of what Knossos was. I won't go through all the rest of the detail, but it's absolutely fascinating, because the theory he comes up with is that Knossos was not a city, it was a necropolis, a city of the dead, which is why people didn't walk around in it very much. And what was very interesting to me about this particular book, I mean, I can't tell you whether it's true or not, I'm not an archaeologist, but simply as an exercise in going back to the data and deriving a more logical model from it, it was absolutely fascinating. So we all select different data from the world out there to create our models. I once went looking for rhinoceroses. Rhinoceri. Which is it? Rhinoceri. Well, it doesn't matter, it was only one. It was a rhinoceros. And there was a small bunch of us, there were 5 of us, going to try and get close to this rhinoceros. It was a northern white rhinoceros in Zaire. We discovered a very interesting thing, which is that you can get quite close to it if you play Grandmother's Footsteps. I don't know if that name means anything over here. In England, it's the name we give to the children's game, where you creep closer and closer to somebody who's got their back turned to you or towards you, and if they turn around and catch you moving, you're out, you're dead. But if you freeze at that moment, then you're okay. So the rhinoceros was sort of chewing around on the grass, and we were able to creep closer and closer. And every time a movement would attract its attention, you'd stop and freeze, whereupon it couldn't see you anymore. And it would think, oh, obviously nothing's there, so it carry on eating. It was only when the wind changed direction and suddenly we were upwind of it rather than downwind that it suddenly knows all about us and makes its escape. I always thought it was us who meant to make our escape, but there you. And the point is, as I discovered, that rhinoceroses use sight the way we use smell, and smell the way we use sight. We tend to use smell as a kind of, just an indication that something may be wrong. Ever since we stood up and lifted our nose off the ground, and our noses are now, well, mine is about 6 feet off the ground, and you can't really smell very much from up here, so our sense of smell is kind of decayed. So we tend to use it just to tell us something's gone wrong, if there's a gas leak or whatever. But then, if you really want to know what's up, you go and find what's happening by looking at it. The rhinoceros is the other way around. It uses sight just as a sort of general alarm signal, and smell as a way of modeling the world. Now that is an utterly, utterly extraordinary idea. I talked about dolphins earlier. Dolphins use sound very often to model their world. And there's a very interesting difference between sound and light. When you consider we use light to model the world, i.e. the model, what we see comes to us in the form of light, which is, which as we know travels at 186,000 miles per second, which to all intents and purposes instantaneously, which means that the order in which things present themselves to our senses is actually the same order in which they've happened out there. In the case of a dolphin, that's not quite true because sound only travels at 1,100 feet per second. But in the case of a rhinoceros, something really weird is happening because it is able to respond to all kinds of fantastic level of sensitivity to all the smells around it, and it can detect what smells have been around for the last 2 minutes, the last couple of hours, the last day. It can tell if another rhinoceros was here yesterday, how it moved around, what kind of mood the other rhinoceros was in. Was it being attacked by something? Was it on heat? Was it hungry? Was it frightened? All these kinds of things. It's there in the air around it. So if you think that it has a model in its mind of the world around it, and the incoming data is updating that model, what kind of world is it looking at? It must be looking at a world in which you see time as a landscape. Now that's very, very odd for us to try and consider because the only world we've ever had any experience of is the virtual world in which we human beings live because we're all human beings. And the only people we've ever spoken to about it are other human beings who share the same idea. So if my slightly fanciful idea that maybe rhinoceroses live in a completely different relationship to time than we do, we wouldn't know. Evolution has determined what type of data we use to create the models that we use from. In the case of, for instance, the dolphin, there's a dolphin I once went to try and find, which is the Baiji dolphin, the Yangtze River dolphin, which is an almost blind dolphin. The reason it's almost blind is that there's nothing to see in the Yangtze River. Thousands of years of agriculture along the banks of the Yangtze have washed so much silt into it that gradually it could see less and less, and so its eyes gradually atrophied while its ability to model the world in sound got more and more sensitive and powerful and strong. And so it was able to, enabled to make that adaptation. It now faces a problem because we've now invented the diesel engine, which means that the Yangtze River is now full of noise. But there are other kinds of animals, like bats, for instance, that work on sound because they're nocturnal, so light isn't going to work for them, so they model stuff in sound. So there are all kinds of different ways in which evolution tends to lead one animal or another to model the world in different kinds of ways. Now, I have a rather serious announcement to make. You may want to brace yourself for this. Human evolution is at an end. It is finished. It's official. The point at which it finished was the point at which we first started to learn to use tools. I'll give you an example of how it works. The sort of thing that drives evolutionary change is this. When some small group of a particular population of animals gets separated off from the main body and finds itself in some new environment. Maybe there's been some geological upheaval, maybe it's pressure of population, shortage of food, forces some small group to go off to a new environment. And let's say, in this case, a small body of animals has gone off to a new environment where it's much colder, or just a little bit colder. Come back in a few generations, and those genes that favor thicker coats will have come to the fore, and you'll find that the animal has developed over a few generations much thicker coats. Now, human beings go about this in a different way. Now, we have learned to live in all parts of the world. We can live in the Sahara, we can live in the tundra, we can live in We can live in the Gobi Desert. We can even live in New York, for God's sake. We can live anywhere. Because what happens is if we move somewhere where, say, it's a little bit colder, and remember we're tool users, we move somewhere a little bit colder, we don't wait for generations to go by while nature brings forward those genes that give us a thicker coat. We see an animal that's got a thicker coat, we say, we'll have it off him. So we can continually protect ourselves from evolutionary change. So now, we live in a world in which if you're sick or injured, you don't die. If the harvest fails, you don't die. If it's suddenly very, very cold, you don't die. If you're rather sort of slow-witted, you don't die. If you're thoroughly stupid, you get elected to high office. And what has happened instead, as a kind of substitute for any physical evolution, because we've kind of taken charge of what happens to us, we've created this buffer zone between ourselves and our environment, so that the abrasion that the environment usually forces on an entity doesn't happen. So instead, we have this culture we've created, and that first thing, that first use of tools and tool use came from the ability to put things together in our head, to model stuff in our head, to put concepts together, to see some little thing that you learnt about the action of a sharp stone that you learnt in one context, and the effect of a sharp stone in another context, and you learn to sharpen a stone and take it somewhere else. And you do that by putting these things together in your head, and then being able to create tools and create more tools, and use these to change our world. So it's that ability to model stuff in software in our heads that has led to us creating this enormously complex culture which we live within, and which is the medium of our communication and is our protection from the environment. Now, it was that tool use, that ability to model stuff in software, that led to the explosive rise of human culture. Curious parallel to that is what happened to the personal computer. Because personal computers were around for a few years, used by hobbyists and kids and anoraks. We were encouraged to think they'd be very useful things for storing our recipes in. The thing that led to the explosive takeoff of computers was a program called VisiCalc, designed by Dan Bricklin. The point about VisiCalc was it enabled us to model in software something. We were unable to model something in software before we tried it out in the real world. You were able to take a whole business plan, a whole financial strategy, try tweaking a percentage point here, try taking a cent off there. How does that sweep through the whole picture? And we were able to do detailed models in software before we tried it out in the real world, and that was the moment at which the computer itself became an enormously useful tool, and that was what led to the explosive takeoff of the personal computer. Now, for a long time, we weren't really very clear about what computers were. I certainly wasn't. I remember the first time I ever saw a computer, a personal computer. It was a Commodore PET. It's kind of a little sort of pyramid kind of thing, sort of huge, great sort of body with a tiny little screen. And it was sitting in a hardware store in London, England. And I went in and had a look at it and thought, well, this is a kind of great kind of thing. This is a kind of wonderful sort of thing. And I was sort of fascinated by it, but I just couldn't think. I couldn't imagine what possible purpose it could serve for me because I was a writer. What use could a computer possibly be to a writer. And I puzzled about this. I have to say that I did, nevertheless, despite the fact that I couldn't see any possible use for it, I did suffer the first tiniest pangs, the first sort of inklings of something that subsequently was going to give a whole new meaning to the phrase disposable income. But the reason that I didn't understand why it could possibly be any use to me was I had the wrong idea of what it was. I thought it was an adding machine. And this is what everybody thought it was. Everybody thought it was a kind of super adding machine and developed it as an adding machine. And after a while, we get so adept at adding up numbers and manipulating numbers that you begin to think, well, we can make these numbers stand for something else. And we make the numbers stand for, let's say, the letters of the alphabet. And we invent ASCII code. And suddenly we say, God, we were so stupid. We were so short-sighted. Why do we think it was just an adding machine? It isn't an adding machine. It's much more wonderful than that. It's a typewriter. And we develop it as a typewriter with a long feature list. Then we look at it again, and our number crunching ability has got a little faster and a little more sophisticated. So we say, okay, let's make each number stand for the elements of a graphic display, for pixels. And we suddenly realize, oh God, we were so short-sighted to think it was just an adding machine or a typewriter. It's a television with a typewriter in front of it. We've now gone to another iteration with the World Wide Web. Because we're now saying, it isn't any of those things. It isn't just a stupid television. It's a brochure. So we are developing it as a bunch of 1 million brochures. The point to bear in mind is that it isn't any of these things. It isn't an adding machine. It isn't a typewriter. It isn't a television. It certainly isn't a bunch of brochures. But it is significant that each of these things which we previously knew about and knew how to use and knew how to work, adding machines, typewriters, televisions, brochures, we modeled in the computer. Because the computer isn't any of these things, but the fact that we are able to model those things in it tells us what the computer is. It's a modeling device. And it's only when we begin to understand that we're going to be able to start really doing useful things with it. We have to abandon our old models in order to be able to think of the thing as a modeling device itself. Now, I often speak, over the last few years, I've spoken from time to time at publishing events or television events or journalism events, and there was a whole phase when people would come up to me and say afterwards, yeah, I hear you know something about computers. And I'd say, well, yeah, a little bit. And they said, well, we're terribly interested and a little bit worried. So what exactly is the effect of computers going to be on the publishing business? Or what is the effect of computers going to be on the television business? And largely they were hoping for the answer, not very much. But the issue really was this, that if you have to ask the question, then you're not ready for the answer. Because it's rather like the Mississippi River or the Amazon or the Nile saying, well, what effect is the coming of the Atlantic Ocean going to have on me? And the answer is that river rules will no longer apply. And you'll be able to tell the people who are out there in the middle of the Atlantic Ocean trying to build riverbanks around themselves, because they'll be the people who are going out of business. Because we have to think in terms of new models. We have to understand what it means when every form of data we have, every type of medium we have, every type of information, every type of experience we might have can be expressed in the same language and is out there in this digital ocean. We select from that ocean of data, and we model the data we choose in ways that make sense to us, in the same way that a dolphin does, or a rhinoceros does, or we do. But human beings now have this extension of our ability to model things. We have an extension to our mind, if you like, the extension to that important part of our mind, the ability to model things, the ability to model things in software. Most animals have an extension to their neck or their running muscles. We have an extension to our brain, an extension to our ability to think and to model. How are we going to make these two things work together? How are we going to make the modeling device we have in our brain and the modeling device we have in these computers work together in a way that makes sense? How can they enhance each other? Well, there are good ways and there are bad ways. So a very interesting, very bad way. Years ago, when I first visited the Media Lab, it was actually the Architectural Machine Group then, it wasn't even the Media Lab. And when I give you this example, I don't in any way wish to denigrate the work of the Media Lab. I mean, because it's actually making silly mistakes that you learn an awful lot from. Now, this particular experiment, if you like, was designed to try and deal with this problem. It was assumed that we would never ever have enough bandwidth to give us working video phones, that we were going to be restricted to the amount of bandwidth we currently get over copper, which just gives us analog sound that's not terribly high quality. So they're trying to figure out, is there a way in which we can sort of simulate simulate the working of a video phone using this relatively narrow bandwidth? And one bright spark had come up with this idea, which is an awful lot of people you speak to on the phone, you speak to quite regularly. So why don't you have stored at your end a picture of the people who call you? Well, you have a picture of your wife, a picture of your mother and your brother and your best friend and your boss and so on. And whenever any of them call you, the phone will know, we'll be able to tell the number it's coming from, and will flash up the picture of the person on your screen. And the incoming sound, the incoming phonemes coming in over the line will waggle their mouth. Now you can imagine how completely absurd this looked. It was just completely ridiculous. It was like something out of Python. But hello, my dog's died. You know, it's sort of. But it wasn't merely completely ridiculous. It was actually self-defeating in a kind of rather ingenious way. Let me see if I explain. Now, when we talk to somebody, if I'm standing talking to somebody directly, then we are reading an awful lot of information off each other. It's not just what I'm saying. It isn't the grammatical, semantic content of what I'm saying. It's the whole tone of voice. It's the whole way I gesture. And I know I gesture an awful lot. When I was young, my mother, if she wanted me to shut up, made me sit on my hands. The whole way our face moves. We're communicating in virtually everything we do as we speak to somebody. If you start to compress that bandwidth, suppose you can't see the person, but you can hear them, you can get an awful lot. We're so adept, we are so fantastically adept at understanding, at communicating with understanding what other people say to us and what they mean, and deriving all kinds of information from what they say, that even if we can't see them, we will actually fill that missing part of the bandwidth with information that we derive from just what we can hear. And if you squash the bandwidth more and more and more and more and more till you get down to telephone quality, then because the degradation of the sound signal has been done, if you like, gracefully, we are still able, with the processing power we have, to decompress that very, very narrow bandwidth of information to fill most of the rest of the missing bandwidth. We can fill it up. Unless the computer, in this instance, has gone in there and filled it up already with junk. So it's important to understand what we are good at and what the computer is good at, and make sure we don't mismatch the things. This was a very, very bad mismatch. Now here's a more interesting, good way of using the computer's ability to model and our ability to model to enhance each other. This is an experiment I read about in something called haptic virtual reality. Haptic virtual reality is one which is not merely immersive and stereoscopic vis-a-vis sight. It also has some sort of tactile feedback. This can be provided, and it was in this particular instance, by a lever that you can move with your hand. And because our hands are fantastically delicate and sensitive to movement and to pressure, it can be a very, very delicate and powerful way of controlling and guiding something. So in this particular instance, what was being modeled was a problem. And the problem was a rather complicated one. It was a road has got to be built through some rolling hills, and there are certain constraints on this road. One is, as you're driving it across the hills, you want to keep the road as flat as possible so that there aren't a lot of up and down gradients, but you also want to make it as straight as possible so there aren't a lot of bends. Now, those are obviously two opposing constraints. If you add to it another constraint, which is there are a lot of houses along the way in these hills, and any house you knock down in order to build your road, you've got to buy. So there's a major expense issue here, a major expense factor in how you determine the track your road is going to take through these hills that are first of all rolling hills and covered with houses. And the answer is that you build all kinds of resistances into the lever, which is effectively a 3D stylus that you're going to try and draw the route of this road through the hills with. And you have a resistance going side to side because the road mustn't waggle too much. You have a certain amount of inbuilt resistance going up and down because you don't want the road to go up and down too much. And you also have a certain resistance that way depending on how many houses you're going through. So there's suddenly an awful lot of information coming in through this handle. Now, you try and find some other way of solving this problem, sitting down and doing the numbers. It's enormously complicated because you've got so many conflicting, interlocking variables. On the other hand, you give it to your hand to deal with, and your hand is very expert at resolving all kinds of different variables because we have such enormously intricate nerves and muscles. And very quickly, the subject was able to find a quick and easy and inexpensive route through these hills just by maneuvering the lever through it. So that is a way in which we can take a different set of data from the world out there, do something intelligent in the machine with it, and present it to this modeling device in a way that it can make a new kind of sense out of. Let's think about, we're here to talk about building applications from the internet, and I've got 14 minutes left, so I might have a little word about that. I came across a thing the other day I was rather shocked by, which was the information that most people, even intelligent, educated people, don't know what causes the seasons. Why do we have spring, summer, autumn, and winter? Most people, when asked if they have any kind of intelligent answer at all, will say, isn't it something to do with the fact of being, the Earth's orbit is an ellipse, and maybe it's winter when we're further away from the sun, and summer when we're closer to the sun? Now, a couple of seconds thought will tell you that isn't the case, because when it's summer in England, it's winter in Australia, and vice versa. And in fact, the Earth's orbit is at the moment very, very close to being circular. At other points in its history, it will be more elliptical, but because of the differential speed with which the Earth goes round different parts of the ellipse, the amount of heat being soaked up by the Earth from the sun at any point is actually a constant. So The thing is that it isn't anything to do with the orbit, the shape of the orbit of the Earth around the sun. And it's very, very simple. It has to do with the fact that the Earth spins at a slight angle. It's not completely upright. And so as it goes around the sun, different parts of the world are tilted directly towards the sun at different times of the year. And when you're tilted towards the sun, you're going to have summer, and when you're tilted away from the sun, you're going to have winter, and spring and autumn will obviously, spring and fall will obviously fall in between. So here is a single, simple piece of information that people ought to have. People ought to know that. What can you do with that piece of information? If you felt, well, people ought to know it. Well, one of the things you could do is you could put it on the web. You could type up the description I've just given you and put it on your home page and invite people who want to know what causes the seasons to visit your home page and read what you've written, and lo and behold, they will then know. Well, I suppose that's quite a good idea. It's using the computer as a typewriter. But supposing we say, well, actually, you can do something a little bit more elaborate than that. You can get an animation program like Director, and you can create a little animation of the Earth going around the sun that will clearly demonstrate the fact that the tilt causes the seasons. And that's a little bit better than what we had before, because you can actually see it happening. But that's using the computer as a television. What might be more interesting is say, well, why don't we create an actual model of the way the Earth goes around the sun, so that when people want that piece of information, they will actually have something that actually is a working model of the thing itself. And while you're doing it, why don't you create a working model of the whole solar system? And if you create it in such a way that anybody else who's then got a piece of information, say, about the trajectory of a satellite or the trajectory of the Galileo or the Voyager or Mariner probes, you can actually put that into the model. And you can fill up this model with more and more and more information about the way the whole solar system works. And anybody then who wants to find out anything about this doesn't have to read something that you've typed or watch something that you made a little animation of, but can go to the actual model itself and derive whatever piece of information they may be looking for from it. Because the model that you create and that anybody out there can actually add to will in the end yield more information than you actually put into it. So if we start to embark on those kinds of exercises, then we are no longer using the computer as a typewriter or a television. We're actually using it as a modeling device, which is what it actually is. The first moment, I guess, it became apparent to me that there was something new and strange happening out in the world, the World Wide Web. The first moment at which I knew something was up, that we weren't in Kansas anymore, that the world was shaking beneath our feet, was something profoundly silly. There was, it turns out, a guy who was working in a university lab, and he was a computer science student, and he used to every now and then go and get himself a Coca-Cola from a machine that was a few hundred yards down the corridor. Sometimes he'd arrive there and find that it was empty, and he'd wasted his journey. So he got a bit fed up with that, and being a hacker, he decided, okay, well, I'm going to put a network connection to the Coke machine so that I can tell from my desk if there's any Coca-Cola in the machine before I have to walk down the corridor. And, of course, one of the effects of putting something on the net is that not only can you read that device from a couple of hundred yards down the corridor, you can read it from the other side of the world as well. And gradually, more and more Coca-Cola machines started to appear on the net. And you could log on to a Coca-Cola machine from anywhere in the world you liked. and discover how many Diet Cokes there were, how many Dr. Peppers there were, how many Fantas there were, when last somebody had taken one of what, when they were last loaded up, what temperature they were. I mean, it was an enormous wealth of completely meaningless information. But the great thing, the great and completely and utterly frivolous, meaningless thing, was that if somebody had gone to that machine and had put 50 cents in the slot and hadn't pressed the button, and you came across a machine in that pregnant state from anywhere in the world, from 10,000 miles away, you could drop that can. And somebody would be walking along the corridor and walking past this Coca-Cola machine, and suddenly, out of nowhere, like a Coca-Cola can would drop out of the machine. Now, I don't know what the person would think. They probably wouldn't have thought it was somebody sending a code from 10,000 miles away that did that. Now, this is not, in the scale of things, an enormously useful thing. It is not a great boon to human civilization, the ability to drop a Coca-Cola tin from 10,000 miles away. But it does indicate something tremendously interesting that has happened. It kind of completes the last side of a square that's been missing in this century. Now let's go back to an earlier form of life, an earlier form of civilization, an earlier form of culture, when we lived essentially local lives, when our lives were bounded by the horizon. Now we would have various kinds of communication with our world. We would talk to each other. I would stand up and talk to somebody else, and they'd talk back to me. One-to-one communication. You'd also have singers and poets who would entertain an audience, or the leader of the village who'd get up and sort of say, this is something here's something we ought to do, and here's a proclamation, and here's a new law, or whatever it is. i.e., one-to-many communications. You'd also have petitions. If everybody feels very strongly about something, they all sort of sign a little piece of paper and send it along to the leader of the village and say, "Oi, this is what we all think. What are you going to do about it?" So that is many-to-one communications. And then we also have the town meeting. Many-to-many communications. Now, in this century, we have found electronic models for all our different types of communication. One-to-one communication, the telephone. You can phone each other up and talk to each other. One-to-many communications. Well, we're flooded with it. Absolutely flooded with it. Radio, television, newspapers, every kind of mass media that exists is one-to-many communications. And it's one of the reasons we lead such extraordinary sort of fractured, crazy lives, because we get information coming at us when we're used to working and inhabiting a completely local world. We're getting information coming at us from all over the world. There's been an air crash here. There's a little girl lost down a well there. All this information that we get terribly worked up about, even though it's thousands of miles away or hundreds of miles away, and however much you react to it, the world doesn't react back to your reaction. It is purely one-to-many communications, and it becomes very, very oppressive. We also now have the ability to do petitions, obviously, on a national basis, so that's many-to-one communications, but never until the web arrived, until the internet infrastructure arrived, did we have the ability to respond back to the world. When the world sends us all sorts of stimulus, previously, however we responded, the world didn't take any account of our response. That last element was missing, the many-to-many communication. The fact that we can reach out in the world and contact, touch, communicate with other people, which is signaled by the fact that you can just quite trivially and pointlessly and frivolously reach out and drop a Coca-Cola can 10,000 miles away. That is what signifies that that last corner, that last square, that last side of the square has been put in place. And suddenly, our means of communication with each other in the virtual world now matches, is now parallel to our means of communication with each other in the real world. And that, I think, is a very significant moment. A little while ago, I was trying to find out, as a matter of interest, what a biologist's definition of life is. It's kind of it's actually quite tricky to try and work out. And we all instinctively know what's alive and what isn't. But trying to define it is actually oddly tricky. I mean, any set of objects that's going to include both Bill Gates and the Great Barrier Reef is going to be hard to define with any sort of great precision. However, there are certain things that you can say that something lifelike will exhibit. Certainly complexity, the ability to organize information within itself, the ability to respond to information, the ability to communicate. All these things are the things that we would think of as being lifelike qualities. Now, the computer itself is not really a very good example of something that exhibits lifelike qualities. But when you consider what is happening in this buffer zone we've created around ourselves, that started with the animal skins we put around ourselves and then went to the bricks and the mortar and then gradually the more and more, all of the enormous complexities of modern life that we have surrounded ourselves, the buffer zone that separates ourselves from our environment. And when you consider that this buffer zone is now something that we are wiring up with enormous complexity by putting all the devices that we use to model our world into communication with each other, so these enormously tangled networks are spreading out through this buffer zone, and the information that is moving through those networks. And this is the most extraordinary facet of the net. As the information moves through the net, part of what's going through it are new pieces of software that will increase the level of complexity and organization in the net. And you'll find messages going backwards and forwards between ourselves, between each other, between the different computers, between the outside world and ourselves, between our environment and ourselves. And gradually, this buffer zone we've connected around ourselves is becoming less and less like the brick walls of a house, keeping out the cold, and more like a virtual epidermis, which is responding to it. So, the message that I would like to try and put across to people as we develop the stuff that's going to go into this wired-up buffer zone that is gradually beginning to form, if you like, the next stage of our evolution, is don't build dead things in it. Don't build dead pages. Build living models. Thank you very much.